where we can see that we are supposed to find the dual of the problem, which is having a constraints of mixture. Some of the constraints have greater than type inequalities, and some constraints have less than type inequalities. So question is how to deal with the problem. That was your question, and that I'm going to answer right now. First of all, that you need to do is the following. Since the problem is of maximization type, we expect by convention all the inequalities to be lesser than type. That is my convention. Now, some inequalities are not lesser than type inequalities, like this one and that one. They are not lesser than type inequality. So we have to deal with that. Then I'm going to show you. So what I am going to do, first of all, I'm going to write the objective function as it is, because there will be no change. We do not have any problem with the objective function, as well as with the first two constraints. In the first constraints, equality symbol is there, only present, and in the second constraint, equality symbol is not present. Only less than type symbol is present. But problem is with the third and the fourth one. The third one, greater than type inequality is present. So what we can do, we can multiply both the side by -1, and we can make it like this. When we multiply two sides of inequality, the inequality changes, because as you know, 2 greater than 1. So when we multiply both the sides by -1, we get -2 and -1, but the inequality changes. Okay, so therefore here we are going to multiply the inequality by -1, and we get -x1 less than or equal to -4. And similarly, this one is -x2, which is less than -3. So that all the inequalities become less than type inequality. And we write x1, x2 greater than or equal to 0. So first job, that before we write the matrix form of the primal, or we try to find out the dual, we have to perform this particular task. So this is important. This particular task is important, so that we can convert all the greater than type of inequality, if present, as less than type inequality. Okay. Next, we are going to write the thing in the matrix form. So in this particular case, we can consider this particular step to be step 1. Writing the problem in its matrix form is not my step 1 any longer for this particular problem. It becomes step number 2. So we write max z 6 -3. This is the matrix, and the vector is x1, x2. Okay, subject to 3x1. So the coefficient is 3, 2, 1, 2, -1, 0, because x2 is not present, and 0, -1. Okay, and less than or equal to, because if you consider the equality symbol, if you put the equality symbol here and here, there will be no problem with that. No problem. You can always put equality sign, because equality sign, because an equation which is less than something or greater than something actually imply a region. Okay, so if I put the equality for the sake of doing the maths, there will be no trouble. Later we can remove the equality. After we construct it, we can remove the equality if required. So putting equality to some region, some extra points, some set of extra points will not do much harm to the given problem. So for the sake of the problem, we can consider all of them as inequalities. Sorry, inequality with the equality symbol involved. Okay, so we can do that. And on the right hand side, we can write it as 25, 16, minus 4 and minus 3. And x1, x2, these vectors are greater than or equal to 0, because these are the decision variables. Now in step number 3, we are going to write the dual of the given problem. So here we are going to construct the dual. So max problem becomes mean. So we write mean W. In place of 6 minus 3, we are going to write the transpose of the column vector, transpose of this column vector. So it will be 25, 16, minus 4 and minus 3. How many constraints are there? In this particular problem, there are 4 constraints, 1, 2, 3, 4. And therefore, the variable will be, number of variables present here will be 4. Y1, Y2, Y3, Y4. Because there are 4 constraints. And these will be subject to the coefficient of this matrix, the transpose of this matrix. So that would be 3, 1, minus 1 and 0. This would be 2, 2, 0 and minus 1. How many variables you are going to consider? Y1, Y2, Y3, Y4. What is the order of the first matrix? The order of the first matrix is 2 cross 4, and the order of the second matrix is 4 cross 1. So this matrix multiplication is possible. Lesser than equality will become greater than equality. So we'll write greater than equality. And in place of the requirement vector, we are going to put this transpose of this given matrix. So it would be 6 minus 3. Y1, Y2, Y3, Y4. This matrix, transpose of this matrix is greater than or equal to 0. 0 matrix, 0, 0, 0, transpose. Since there is no space, so I'm not writing it in column wise. So therefore, I have written it in a transpose form. Okay, like this. So this is the dual of the given problem. Now we have to do a bit of calculation over here. We have to write it in a concrete form as the primal problem is given. Primal problem is given in this manner. It is not given in the matrix form. So we have to consider this particular matrix form, and we have to bring it back into the original form that from which the matrix form was derived. Can I go to the next page?
Yes, sir.
Okay. So it becomes mean W, therefore mean W, which is equal to multiply the matrix, it would be 25y1 plus 16y2 minus 4y3 minus 3y4 minus 4y3 minus 3y4 subject to multiply this 3y1 plus y2, 3y1 plus y2 minus y3 plus 0y4 minus y3, 0 will not be there, and y4 will not be there, greater than or equal to 6. And the second one will be 2y1 plus 2y2, 2y1 plus 2y2, y3 will not be there, minus y4 greater than or equal to minus 3. and y1, y2, y3, y4, this transpose is greater than or equal to 0, 0, 0, 0 transpose. But there is a problem. The problem is, it is a convention that we cannot put negative sign on the left hand side, right? On the right hand side. Requirement vector is supposed to be always positive. Requirement vector is always supposed to be positive. Okay, and therefore we have to bring it back into its actual form by multiplying again the second inequality by -1. So my final answer to the given problem would be min W 25y1 plus 16y2 minus 4y3 minus 3y4 subject to 3y1 plus y2 minus y3 greater than or equal to 6. Multiply both the sides by -1. We get minus 2y1 minus 2y2 plus y4 less than or equal to 3. And y1, y2, y3, y4 is greater than or equal to 0, 0, 0, 0. This is your final answer. Now, if the equality sign is there, it will not be it will not be of any trouble. Equality can be included, can be excluded also. It is doesn't actually is not affecting the system at all. Greater than equality means the things are actually greater than that. Equality is extra, some extra points are being added for the sake of the problem, but the region remains the region. If we consider x greater than or equal to 3, and if we consider x greater than 3, that means x equal to 3 is the line perpendicular parallel to y-axis. So x greater than 3 means the right hand side of the line. X greater than or equal to 3 means the right hand side of the line including the line, and x greater than 3 means just the right hand side of the line. So it will not be any trouble if I keep the equality sign in the problem. Now, this is the thing that we do when there is a mixture of two inequalities like this. Things become a little bit more complicated when the problem is given in the following form, which I'm going to show you in the next page, in a fresh page. Given, this is another question, given the linear programming problem as max z 2x1 plus 3x2 plus 4x3 subject to x1 minus 5x2 plus 3x3 is equal to 7, 2x1 minus 5x2 less than or equal to 3, 3x2 minus x3 greater than or equal to 5, x1, x2 greater than or equal to 0, and it is given that x3 is unrestricted in sign. X3 is unrestricted in sign. This problem is a star problem. I mean, anybody who is comfortable with this problem, he can do other problems also. Any problem, any formulation from dual to primal, primal to dual. Several things have to be maintained first of all in this case. Okay. First of all, you need to check that whether the given problem, okay, what we are supposed to find, the question has not been given. Question is find the dual of the given LPP. Find the dual. This is the problem. Now carefully listen to me. First of all, what we need to do, first of all, you check what type of problem this primal problem is. It is a maximization type of problem. So your immediate requirement is to bring all the inequalities into lesser than type of inequalities. That is the first thing that you are going to do over here. Problem is with the two constraints. First constraint is this one, where equality symbol is there. And the second constraint is this one, where greater than equality is there. Now we know that how to convert a greater than equality. We just have to multiply both the side by -1. But what about the equality? How can I bring less than type inequality over here in place of equality? How can I do so? If there is a less than type thing, we can include equality. But if there is equality, how can I bring the region into existence? That is the thing. Now, for this, what we need to know a bit of real analysis, which tells us that if x is a real variable, okay, and a is a constant which is also real, then x less than or equal to a and this statement and together with x greater than or equal to a, this statement, if they together happen, it implies actually x equal to a. This you know, this you have to know, and that I'm going to apply over here. Now you see this particular thing, this particular expression is an expression containing 3 variables. Okay, it is equal to 7. So what we can do is the following, implies max z 2x1 plus 3x2 plus 4x3 subject to we can apply this particular rule over here, x1 minus 5x2 plus 3x3 less than or equal to 7, and at the same time x1 minus 5x2 plus 3x3 greater than or equal to 7 together by this rule. And the third one is 2x1 minus 5x2 less than or equal to 3. And the fourth one is 3x2 minus x3 greater than or equal to 5. x1, x2 greater than or equal to 0. x3 is unrestricted. This is the first job that you are going to do over here. x3 is unrestricted. So this is the thing that you are going to do, first of all, to bring inequalities from the equalities. Next important part is this one. x3 is unrestricted. What do we mean by that? Actually, we know that in linear programming problem, okay, we can write it as step number 1. We know in linear programming problem that all the variables need to be greater than or equal to 0 because they are decision variables and they are physical variables. Here we know that x1, x2 greater than or equal to 0, but regarding x3, no sign is given. x3 is unrestricted means x3 is unrestricted in sign. We do not know what is the behavior of the variable x3. So what we can do is the following. This is the rule. So many rules are there, operation research. x3, if x3 is unrestricted, we consider x3 as the difference of two new variables, x3 difference x3 double prime, x3 prime difference x3 double prime. Achha, I do not have space over here, so I'm writing in this place. x3 as x3 prime difference x3 double prime. Two new variables we have introduced over here. New variables. They are all new variables. This symbol is called the difference symbol. This symbol is known as the difference symbol. It means two things. First of all, it means x3 prime minus x3 double prime if x3 greater than x3 prime greater than x3 double prime, and it means x3 prime double prime minus x3 prime if x3 prime less than x3 double prime. This is the meaning of the symbol difference. I'm moving very slowly so that you can catch everything that I'm telling you right now. It's a long problem, so it needs time. Before we make the formulation. Formulation part is simple. I mean, the conversion part is very simple. But the managing of the problem before we go for the conversion is a little bit difficult. So this is the problem. This is the ultimate problem that can put you in trouble. So first of all, we have to take care of the equality sign. Here we are taking care of the equality sign. This is the first page. And next we are taking care of the unrestrictedness of the variable. Okay. So what we are going to do, we are going to replace every x3 present over here. How many x3s are there? Here there is an x3. One x3 is present here, another x3 is present here, another x3 is present here. All the x3s will be replaced by difference of two variables. Okay, two new variables. Keep in mind that these variables, new variables, x3 prime and x3 double prime, they are obviously non-negative. x3 prime and x3 double prime, they are not unrestricted. They are greater than or equal to 0. That rule you need to know. You need to remember to proceed with the given problem. Otherwise, you will not be able to proceed. So I'm going to the next page. Take a screenshot of this page quickly. Okay. So implies step number 3. So we write max z and 2x1 plus 3x2, 2x1 plus 3x2, and in place of x3, we are going to write 4x3 prime minus x3 double prime, assuming that x3 prime is greater than x3 double prime. This is my assumption without loss of generality. Okay, subject to, you can assume the second one also, that there will be no change because these are just the naming of the variables. x3 double prime minus x3 prime means x3 prime is greater than x3 double prime. x3 double prime is greater than x3 prime, and you can rename the thing because these are just the matter of renaming the variables. Okay, so you can either choose this one or that one, doesn't matter. We are going to do the same thing with all the constraints. So in the subject to x1 minus 5x2 plus 3 into x3 prime minus x3 double prime, which is less than or equal to 7, x1 minus 5x2 plus 3 into x3 prime minus x3 double prime greater than or equal to 7, 2x1 minus 5x2, 2x1 minus 5x2 less than or equal to 3, and 3x2 minus x3. So 3x2 minus x3. So in place of x3, you are going to write x3 prime minus x3 double prime greater than or equal to 5. Greater than or equal to 5. And you can write, after the introduction of these new variables, you can write all of them are greater than or equal to 0. Okay, so this we have done in this particular case, taking of the unrestrictedness, taking care of unrestrictedness. I have not gone into the details of finding dual at all. I'm just reshaping the problem, the primal problem. It is called the reshaping. All this step 1, step 2, step 3, these are the reshaping of the primal problem to my convenient form that I am capable of managing. Implies a little bit of recalculation. We can write this as 2x1 plus 3x2 plus 4x3 prime minus 4x3 double prime subject to x1 minus 5x2 plus 3x3 prime minus 3x3 double prime less than or equal to 7, x1 minus 5x2 plus 3x3 prime minus 3x3 double prime greater than or equal to 7, 2x1 minus 5x2 less than or equal to 3, 3x2 minus x3 prime plus x3 double prime greater than or equal to 5, x1, x2, x3 prime, x3 double prime greater than or equal to 0. If you are comfortable with this sort of calculation, then you can avoid this step. You may avoid this step if you want, but one thing will happen if we avoid, because you may lose some signs. So for example, if you are not careful enough while writing the matrix form, you can do mistakes in putting signs preceding the variables. So therefore, I suggest not to avoid this. Okay, not to avoid. Now your job, I think my problem is little bit.
And not to avoid which one?
Not to avoid this step. Write this step. Write this step. If you, even if you, this particular step seems to you silly, that I have done nothing extra over here. I have just multiplied the things. So someone may think that, okay, why we can easily understand from here. We can easily write the matrix form, but still you have to do, because signs are there. Some minus sign is preceding this bracket. So if you remove the bracket, this variable is preceded by a minus sign. Second one is being preceded by the plus sign. So you, since you are doing for the first time, you may do some mistakes over there. So write this step. That is my advice. My problem is to some extent reshaped, but still I want to reshape it further. Why? Because carefully observe, just like my previous problem, in this particular problem, we have greater than equality symbol. And here in this particular problem, we have less than or equality symbol. So we have to make them all less than or equality, because it is a maximization type of problem. So that is my step number. This is actually an extra step. This is extra step.
We can directly move step 2,
Yeah,
step 3 to step 5.
Yeah, you can directly move from step 3 to step 4. I'm writing it at step 4.
Yeah, yeah.
Okay,
Yes,
so we can write it as max z 2x1 plus 3x2 plus 4x3 prime minus 4x3 double prime subject to x1 minus 5x2 plus 3x3 prime minus 3x3 double prime less than or equal to 7, x1 minus 5x2 plus 3x3 prime minus 3x3 double prime. Okay, sorry. I have to multiply this side by -1. We have to multiply this side by -1 so that it becomes less than or equality. So minus on that side, minus on that side. And we get 2x1 minus 5x2 less than or equal to 3. Again, multiply by -1, we get 3x2 minus x3 prime plus x3 double prime less than or equal to -5. And x1, x2, x3 prime, x3 double prime, they are all greater than or equal to 0. And this implies max z is equal to 2x1 plus 3x2 plus 4x3 prime minus 4x3 double prime subject to x1 minus 5x2 plus 3x3 prime minus 3x3 double prime less than or equal to 7 minus x1 plus 5x2 minus 3x3 prime plus 3x3 double prime less than or equal to -7, 2x1 minus 5x2 less than or equal to 3 minus 3x2 plus x3 prime minus x3 double prime less than or equal to -5, x1, x2, x3 prime, x3 double prime greater than or equal to 0. Just note it down carefully because I have to write it also in my copy because I'm going to lose this particular session after a few minutes. I'll not be able to continue if I lose this particular expression. So just let me quickly somewhere note it down. Just a minute. From this particular point, we are going to start our next session. So blue colored portion is actually very important. So just copy it. We have 6 minutes left for the current session. Now, probably you are thinking that, okay, if you were to sit for offline examination, and if this problem comes, the mark of the problem will be around 6 to 7. I do not know whether this mark will be sufficient for you, but this is the standard mark for the given problem. And if you are not sitting for the offline examination, probably you are thinking that why to worry so much about the given problem because we don't have to do it. Oh, so what is the objective of doing this great big calculation? It is because once you finish the calculation, something will come out of it. Some information will come out of it. And in the online examination, you may be asked about that information. Okay, so I have written it down. So now see this, the shaping that I have made over here. This shaping is the shaping that I want to bring from the original one, because now the problem is a maximization type of problem. All the inequalities are less than type of inequalities. And then we are going to write the dual very easily. The formation of dual becomes very easy right now. So in step number 5, we write the dual of the given problem. Oh, before that, not that. In step number 5, we are not going to write the dual. We are going to write the matrix form of the given problem. Matrix form. So what is the matrix form? Max Z 2, 3, 4, minus 4. How many variables are there? x1, x2, x3 prime, x3 double prime, subject to 1 minus 5, 3 minus 3, minus 1, 5, minus 3, 3, 2x1. So 2, no x2 is there, minus 5. No x3 is there, no x3 prime is there, no x3 double prime is there. So 0, 0. And 0, no x1 is there. And this is minus 3. x3 prime coefficient is 1. x3 double prime coefficient is minus 1. And x1, x2, x3, x3 prime, x3 double prime less than or equal to 7 minus 7, 3 minus 5. x1, x2, x3 prime, x3 double prime, they are all greater than or equal to 0. This is the matrix form. This is the matrix form. In the next session, we are going to write its dual, not in this session. Because after writing the dual, we have to do a lot of other things. Because just writing the dual and calculating the expression will not do the job. We have to take care of some other situations that actually have crept in this particular problem. So I'm also going to actually writing in my copy so that I can take the reference in the next session. I shouldn't. Yes, yes.
Say 7 or minus 7 এর যে লাইনটা ওটা তো সেম লাইনেরই দুটো পার্ট, তো ওটা একটা ম্যাট্রিক্সে কেন হলো? ওটা তো সেপারেট দুটো ম্যাট্রিক্স করে, একটা ম্যাট্রিক্সে অনলি 7 দিয়ে একবার ক্যালকুলেশন, দেন আরেকটা ম্যাট্রিক্স করে মাইনাস 7 দিয়ে ক্যালকুলেশন করতে হবে না?
না না, একটা ম্যাট্রিক্সের একটাই পার্ট, কারণ এটা হচ্ছে বিকজ জাস্ট এ মিনিট, এটা একটা এটা হচ্ছে গিয়ে বিকজ
স্যার এটা তো আমরা